Welcome to the deep dive. Today, we are plunging into the foundational ideas of sustainable design. We're using a really comprehensive source here. It's a book called Sustainable Design Basics.
That's right. And sustainable design, well, it can feel incredibly vast, can't it? Really complex, like trying to navigate a whole new world of information sometimes. So our mission in this deep dive is to kind of act as your guides. We want to help cut through some of that complexity, help you quickly grasp the core principles, and also a practical methodology drawn straight from this text.
Think of it as, your shortcut. Understanding not just why sustainable design is so critical today, but also how designers actually approach it step by step. And we'll touch on some truly fascinating strategies they use along the way. So whether you're just curious or maybe you need to get informed pretty fast, we'll unpack it all based on the material right here.
Yeah.
Okay, let's get started.
Okay. So to really get the why behind sustainable design, the book actually takes us back a bit, a quick historical tour almost. It reminds us that human civilization, well, as we know it, it really flourished during the Holocene. That's this rare, stable, warm period we've been in since the last ice age.
Right, the conditions that allowed everything to develop.
Mm.
And then fast forward to the 20th century, and things really shifted gears, didn't they? We hit what the book calls the Great Acceleration, a period where human impact on the planet just dramatically sped up. We saw incredible technological leaps, sure, but also, well, significant environmental consequences.
Exactly. And that stark realization, that understanding of our impact, that's really what fueled the modern environmental movement. The source highlights figures like Rachel Carson, for instance. Her work really underscored that our traditional ways of doing things, building included, often had these significant, unforeseen negative effects on the larger environment.
Which logically leads to rethinking how we measure success.
Right.
The source introduces this core concept, the triple bottom line. It's not just about the financial profit anymore, is it? Sustainable decisions must equally consider the social impact. It's the people part, the environmental impact, the planet.
Yep.
And the economic viability, the profit.
And what's really interesting here is the book actually pushes this a bit further. It adds a fourth layer. Beauty.
Beauty. That's interesting.
Yeah. It kind of elevates sustainable design beyond just, ticking the environmental boxes. It acknowledges that creating spaces that are functional and inspiring, spaces that connect us to our surroundings and, frankly, make us feel good.
Well, that's also a critical part of true sustainability.
So it really isn't just about being green. It's more fundamental. It's like rethinking how we shape the whole built world around us, considering much broader impacts on communities, ecosystems, even our own emotional well-being.
Yeah.
That's a powerful shift. Absolutely. It's huge. And because this shift is so profound and there were just so many considerations, the book presents a clear how. It's a methodology they call Sustainable Design Basics, or SDB for short. And it offers this step-by-step guide precisely because, as the book itself notes, sustainable design is inherently a complicated process. It can feel completely overwhelming otherwise.
Right. You need a roadmap for this kind of complex territory. And the method uses, 4 core perspectives to look at everything, sort of filter information, evaluate ideas, make decisions all the way through.
Exactly. Those perspectives are performance, systems, culture, and experience.
Okay. Can you unpack those a little?
Sure. So performance is pretty straightforward, how well something functions.
Yep.
Energy use, light levels, the measurable stuff. Systems looks at the connections, water cycles, material flows, how a building plugs into the wider infrastructure.
Right, the bigger picture connections.
Then culture considers the context, the history of the place, community needs, local aesthetics, things like that. And experience is about how it actually feels to be in the space, comfort, well-being, that connection to nature we talked about. These perspectives basically help break down all the tangible and, intangible layers that influence design choices.
And how do you keep track of all this, especially when you're trying to weigh these different perspectives against each other? It sounds like a lot to juggle.
Well, the book talks about using matrices.
Matrices, like spreadsheets.
Sort of, yeah. They're essentially organizational tools. Think of them like structured ways to collect, analyze, and evaluate information systematically as you move through the project. It's a way to tackle these complex problems by looking at the smaller pieces,
Makes sense.
Break it down. And the methodology breaks the whole process down into 4 main stages, 4 steps. Step 1 is context. Step 2 is pre-planning. Step 3 is design. And step 4 is final validation and presentation. It guides you logically through the whole journey.
Okay, so applying this roadmap, where do we even begin on a project? You said step 1 is context. The book says it's all about starting with deeply understanding what exists right now, doesn't it?
It does. And this is where site inventory and analysis come in. The source really considers this one of the most crucial steps, and honestly, sometimes one of the most challenging. You absolutely have to understand the specific opportunities and constraints of a building site before you even think about putting pen to paper, before you start designing.
And understanding the site goes way beyond just, like, mapping the property lines, right?
Yeah.
It includes looking at the climate, both the macro level, the big picture regional climate,
Mm.
so that arid, temperate, tropical, polar,
Mm-hmm.
and the micro level, those really localized variations, things affected by hills, nearby buildings creating shade, even how air moves differently right there on that specific spot.
Exactly. The book even mentions using simplified climate classifications like simplified Köppen-Geiger categories, just as a starting point for understanding that regional context.
So what are the key factors you're analyzing?
Well, topography is a big one, designing with the existing hills and valleys, not just flattening everything. Understanding how water and air move across the site is vital. And solar conditions, tracking the sun's path, its angle at different times of day and year. Because the sun is, well, it's a powerful potential energy source, or a potential heat problem if you don't manage it properly.
And I was struck that the book even mentions the sounds of the environment as part of site analysis.
Yeah, it's a subtle point, but important. The sounds provide cues, don't they, about time of day, the season, and they definitely affect our emotional state in a space.
That's fascinating. So it's not just the physical, it's the sensory too.
Right, and the context analysis goes even wider to the macro level, looking at settlement patterns. Is it urban, suburban, rural? Factors like how dense the area is, what infrastructure already exists, access to public transit, all that shapes the design possibilities and the potential impacts.
The book also talks about different site types, right? Like
Right.
brownfields.
Yeah. Brownfield sites previously developed, maybe industrial use. Grayfield sites like abandoned malls or parking lots. And greenfield sites, basically undeveloped land. And it stresses the need for real sensitivity and careful consideration, especially when you're thinking about developing those previously untouched greenfield areas.
So really digging into the physical, the biological, even the cultural layers of a site right at the start.
Yeah.
That's what uncovers the fundamental challenges and opportunities that will guide everything else. It's the essential foundation.
Absolutely essential. And once you have that deep understanding of the context from step one, you move into step two, pre-planning. This is really where you refine the mission for the project and set clear goals.
Okay.
The book suggests starting with background research, looking at case studies or precedents, as they're called, basically learning from past experiments, seeing what worked on successful projects that faced similar conditions or had similar goals.
Learning from others' experience makes sense, both successes and maybe failures too. And this step is also fundamentally about setting clear goals and specific, measurable objectives for this particular project, right?
Exactly. The broadest goals often get captured by those classic R words: reduce, reuse, recycle, and also restore. Thinking about actually improving the site conditions.
Okay, general goals like reduce energy use,
Yeah.
but how do you make them specific?
That's where objectives come in. They need to be specific and, crucially, measurable. And to measure them, you need metrics. The source highlights some key performance metrics, or KPIs.
Like what?
Things like energy use intensity, or EUI, basically how much energy a building uses per square foot per year. That's a big one. Or specific targets for daylight levels in rooms, indoor air quality metrics like the percentage of space near operable windows, or targets for total water consumption.
So you have actual numbers to aim for.
Precisely. Benchmarks provide those specific numerical targets.
Yeah.
It's not just saying we want it to be energy efficient. It's saying we want to achieve an EUI of X.
Got it. Quantifiable goals. This step also includes basic space planning too, doesn't it? Figuring out what spaces are needed and how they relate.
It does. The book suggests using tools like a criteria matrix again. Remember that tool?
Yeah, the grid for organizing information.
Right. Here you use it to organize the spatial needs and relationships, looking at them through those four perspectives. Again, performance, systems, culture, experience, and creating relationship diagrams like bubble diagrams to visualize how different spaces should ideally connect physically and functionally.
So you're really laying all the groundwork here, defining the problem, setting the targets, figuring out the basic spatial needs.
Exactly. As the source puts it, all of the background information, research, and analysis from steps 1 and 2 are synthesized into a coherent understanding of the design problem before step 3 is undertaken. You need this solid foundation.
Which brings us logically to step 3, design. This is where the drawing starts, metaphorically speaking. The creative process takes off. But it's framed by all that rigorous analysis you did earlier.
Right. And the book describes it as an iterative process.
Iterative, meaning you don't just get it right the first time.
Pretty much. It means you explore ideas, you test them, you refine them, maybe you discover something and loop back. You explore multiple potential solutions, and those four perspectives and the design matrices, they come back into play here constantly. You use them to evaluate and prioritize different design ideas as they evolve.
So it's a way to keep checking, are these cool ideas actually meeting the goals we set for performance, systems, culture, experience?
Exactly. It keeps the design anchored to the project's objectives.
Now, within this big design step, the book provides some really helpful deep dives into specific areas, right? Highlighting crucial sustainable strategies.
It does. These are where you see the principles applied in practice.
Okay, let's jump into some of those then. Maybe starting with passive design. That sounds fundamental.
It really is. Passive design is all about leveraging the forces that are already there on your site. The natural forces, climate, sun, wind, using those to provide heating, cooling, ventilation, and light, ideally reducing the need for energy-hungry mechanical systems like furnaces and air conditioners.
Right.
The source calls them the first strategies to be integrated because they work with nature, not against it.
That makes so much sense. Don't
Uh-huh.
fight the site, work with it. So for passive heating, what does that look like?
Well, the book talks a lot about maximizing solar gain, especially in winter when you want the heat. That means orienting buildings carefully, using equator-facing windows south-facing in the northern hemisphere to capture that low winter sun.
Okay, let the sun in.
And crucially, using thermal mass. Think thick concrete floors, stone walls, maybe even water containers, materials that can absorb that solar heat during the day.
And then release it slowly when it gets cooler at night.
Exactly. It helps keep the temperature stable. The book even mentions ancient Chinese homes oriented south for winter sun as a historical example of this thinking. It's not a new idea.
Okay, so that's heating. What about passive cooling and ventilation? Especially important in warmer climates, I imagine.
Absolutely critical. Strategies here include using landscaping trees for shade, maybe berms, or even the building's placement relative to topography to shelter it from harsh winds, while maybe channeling desirable breezes towards the building.
Ah, using the landscape itself.
And designing for natural air movement within the building. Two key concepts are stack effect and cross ventilation.
Stack effect, that's warm air rising.
Yeah, warm air rises, so if you have openings high up, it can escape, drawing cooler air in through lower openings. Creates a natural chimney effect.
And cross ventilation.
That's simply letting breezes flow straight through a building by having openings on opposite sides or adjacent sides, aligning windows or vents to catch the prevailing winds.
The book lists some specific tactics for this, right? Some seem surprisingly simple.
They often are. Operable windows, just being able to open a window is vital, simple, yet so effective. Building voids like internal courtyards or atriums can help draw air and light deep inside. Earth tubes are interesting pipes running underground where the earth temperature is stable, used to pre-cool incoming air in summer or slightly pre-warm it in winter.
Wow. Using the ground's temperature.
Then there's thermal mass again, but used for cooling. Paired with night purging, opening windows at night to flush the building with cool air, which cools down that mass. The mass then helps absorb heat during the next day.
Smart.
And strategic shading is huge. Things like roof overhangs, awnings, or vertical fins on the outside of windows to block unwanted high summer sun, especially on east and west facades, while still letting in lower winter sun for heating.
So it's really designing the building's shape and openings very deliberately based on the sun and wind.
Absolutely. The source even shows how a windrose diagram, those charts that map wind direction and speed for a specific location, directly informs where you'd place windows or openings to maximize that natural ventilation potential. You're literally designing with the wind patterns.
That's cool. And these passive strategies apply to water too, not just air and sun.
Definitely. Beyond just standard water efficiency measures like low-flow fixtures, which are important,
Right.
the book discusses rainwater harvesting. Basically, capturing the runoff from hard surfaces like roofs, maybe driveways, into tanks, cisterns, or even ponds.
And what do you do with that water?
You can use it for non-potable needs things that don't require drinking water quality, like flushing toilets, washing clothes, or landscape irrigation. This conserves precious potable water and also reduces stormwater runoff, which can pollute local waterways.
Okay, so passive strategies cover heating, cooling, ventilation, light, and even water. Really fundamental stuff.
Exactly. Now, closely related to passive design is daylighting. Let's move to that. The book makes a really critical point here. Daylighting isn't just an energy-saving strategy, although it certainly is that.
What else is it about?
It's fundamentally about creating healthier, more pleasant, and more productive spaces for people. It's about connecting occupants to the natural world, to the rhythms of the day. It affects mood, alertness.
Makes sense. We all feel better in naturally lit spaces. So what are the key strategies for getting that natural light deep into buildings? Because that's often the challenge, right? Especially in bigger buildings.
It is. Strategies really start with the building shape and how it's oriented on the site. Generally, narrower floor plates, especially when they're oriented with the longer facades facing north and south, tend to allow for better daylight penetration compared to deep, square buildings.
Okay, shape matters. And window design must be crucial.
Absolutely. The book talks about things like the window-to-wall ratio, or WWR, basically, how much of the wall area is glass, and also effective aperture, or EA, which is a more refined measure. It considers not just the size, but the effectiveness of the window in delivering useful daylight deeper into the room, considering things like glass properties and shading.
So it's not just about having huge windows everywhere.
No, definitely not. It's about balancing getting enough light with avoiding problems like glare and unwanted solar heat gain, especially in summer.
How do you manage that balance?
Well, the source describes different types of windows and how placement is really key. It distinguishes between lower vision glass, which is mainly for views out,
Right at eye level.
and higher daylight glass, often placed above head height, say above 7 feet. This high glass, maybe with special high transmission properties, is designed specifically to bounce light off the ceiling and deeper into the space.
Using the ceiling as a reflector.
Exactly. And shading, both exterior shading like overhangs and interior shading like blinds or louvers, is essential to manage that direct sun, control glare, and prevent overheating.
You mentioned overhangs earlier. The book highlights exterior light shelves too, right?
Yeah.
How do they work?
Yeah, light shelves are a really smart strategy. They're basically horizontal elements on the outside wall, often placed above the vision glass. They do two things. They shade the lower window from high summer sun, and they bounce sunlight that hits their top surface up onto the ceiling, sending reflected light deeper into the room. Really effective.
Clever. And what about getting light into the middle of big buildings or single-story buildings where side windows aren't enough?
That's where top lighting comes in. Using skylights or roof monitors, which are like raised sections of the roof with vertical windows or sawtooth roofs, those angled roofs you sometimes see on factories.
Right, with glass and the vertical parts.
Exactly. Those are all crucial for bringing daylight down into deep floor plates or spaces far from exterior walls.
And it's not just about the windows and roof openings. Even the colors inside matter.
They do. The book discusses light reflectance value, or LRV. It's a measure of how much light a surface bounces back. Surfaces with high LRV, especially the ceiling and the wall opposite the main windows, help distribute daylight more evenly throughout the space. They reduce harsh brightness contrasts, making the space feel more comfortable and visually appealing.
So light-colored ceilings and walls are generally better for daylighting.
Generally, yes, especially that back wall.
And finally, the source stresses connecting this daylighting design with the artificial lighting controls, right? To actually save the energy.
Absolutely vital. If you bring in all this great daylight but leave the electric lights blazing, you're missing the point, energy-wise. So systems that automatically dim or switch off the electric lights when there's enough natural light available, those are critical for realizing the full energy-saving potential of a good daylighting design.
Okay, that makes total sense. Maximize the natural, minimize the artificial when you can.
Let's move on to the building envelope itself.
The envelope.
Yeah.
That's basically the skin of the building, right? The barrier between inside and outside.
Exactly. The foundation, the walls, the roof, the windows, the doors, all the parts that enclose the space. The book calls it an assembly of systems because it's really made up of many layers working together: structure, insulation, air barriers, vapor barriers, cladding.
And its job is pretty fundamental, isn't it? Keeping the weather out, keeping us comfortable.
Absolutely fundamental. Providing shelter, maintaining comfortable indoor temperatures, managing moisture to prevent condensation and mold, resisting air leakage, stopping water infiltration. A well-designed, well-constructed envelope is absolutely critical for energy performance. It controls how much heat is lost in winter or gained in summer.
And how its design needs to respond to the climate, I assume.
Definitely. The source explains this well. For cold climates, the priorities are maximizing insulation, high R values, and creating a really airtight seal to prevent warm air from leaking out. Windows are still strategically placed and sized for passive solar gain, but you limit their overall area usually.
Keep the heat in.
Right. But in hot or hot-humid climates, while good insulation and air sealing are still important to keep conditioned air in and humid air out, the focus shifts. You want to minimize unwanted solar heat gain through really effective shading, maybe using lighter exterior colors. And facilitating natural ventilation becomes critical when conditions allow.
So the priorities shift depending on whether you're mainly heating or cooling.
Exactly. The envelope strategy has to be climate specific.
What about the actual materials used in the envelope?
The book touches on this too, discussing structural systems, traditional wood framing, steel, concrete, or newer options like structural insulated panels, SIPs, which combine structure and insulation, and the finished materials, the visible exterior like brick, metal panels, stucco, siding, or glazing systems. When selecting these, the source reminds us to consider factors beyond just appearance or cost. Things like embodied energy, how much energy went into making and transporting the material, is it locally available, how durable is it, will it last a long time?
Lots to consider. And roof design gets specific attention, too.
Yes, roofs are a big part of the envelope and have unique opportunities. The book discusses cool roofs, which use highly reflective materials to bounce sunlight and heat away. This reduces cooling loads and helps combat the urban heat island effect where cities get hotter than surrounding areas. And vegetative roofs or green roofs, planting medium and plants on the roof, they provide excellent insulation, absorb stormwater runoff, create habitat, and also help mitigate that urban heat island effect.
Plus, they can look great.
They can. And the roof shape itself can support passive strategies. We mentioned sawtooth roofs for daylighting. You might angle a roof optimally for installing solar photovoltaic panels or shape it to include clerestory windows high up for light and ventilation.
So the envelope is this really complex, multifunctional system that has a huge
But
impact.
huge impact.
Huh.
Okay, speaking of materials, the book takes a specific look at green materials.
Right. What makes a material green?
Well, it's about more than just being environmentally friendly in terms of resource use or pollution, although that's key. It also has a direct impact on the air quality inside the building, the IAQ and the overall indoor environmental quality, or IEQ.
How so?
The source points out that some common building materials, finishes, furniture, they can off-gas volatile organic compounds, VOCs, or contain other toxicants that can negatively affect human health. Headaches, respiratory issues, that sort of thing.
So material choices affect occupant health directly.
Directly. So, how do designers evaluate materials from this perspective? It's complex. The source introduces life cycle analysis, or LCA.
Life cycle analysis. What does that involve?
Think of it like tracing the entire life story of a material, from extracting the raw resources out of the ground through manufacturing, transportation, installation, its use phase in the building, and finally, its end-of-life disposal, or hopefully recycling or reuse. LCA tries to quantify the environmental impacts, energy use, water use, emissions, waste at each stage of that life cycle.
Wow, that gives you a much bigger picture than just looking at, say, recycled content alone.
Exactly. It's holistic. The book also discusses product certifications and labels as tools that can help designers navigate these choices because doing a full LCA for every single material is often impractical.
What kind of labels are helpful?
It mentions several examples. Things like the Living Building Challenge's Red List. This is a list of particularly harmful chemicals and materials like certain plastics, flame retardants, heavy metals that they prohibit in their certified projects. There are Declare labels, which aim for radical transparency by listing all of a product's ingredients and their sources, and certifications like Ecologo, which is a multi-attribute standard, meaning it looks at various sustainability criteria across the product's life cycle.
So these labels act as sort of third-party verification.
Ideally, yes. They help designers make more informed choices about what's actually in the products they specify and what their broader impacts might be.
What are some key strategies the book suggests for selecting greener materials?
Well, number one is often just reducing the amount of material needed in the first place through efficient design. Less is more. Then, specifying materials with recycled content, both pre-consumer, like manufacturing scrap, and post-consumer, like recycled plastic bottles. This reduces the demand for extracting virgin resources.
Makes sense. Use waste instead.
Prioritizing durability is key materials that will last a long time and won't need frequent replacement. Selecting materials with low embodied energy, meaning less energy was used to make and transport them. Also considering materials that require less water in their processing. And prioritizing materials that are extracted or harvested locally or regionally to cut down on transportation impacts and support local economies.
It sounds like a lot to weigh up for every single material choice.
It really is. And the book offers a really important note of caution here about greenwashing.
Greenwashing. Manufacturers making claims that aren't entirely true.
Exactly. Making misleading or exaggerated environmental claims about their products, the book wisely advises designers and consumers to maintain a healthy skepticism. And it points out that determining if a material is truly sustainable often, well, it depends. It depends on the specific project's context, its goals, its priorities. There's rarely a single perfect answer, which means you really have to do your homework and understand the trade-offs.
Right. It's not always a simple yes-no question. Context matters.
Yeah.
Okay, so we've gone through context, pre-planning, and the big design step with all those deep dives. What's the final step? Step 4.
Step 4 is final validation and presentation.
Validation. So checking your work, basically. Did the design actually meet the goals and objectives you set way back in Step 2?
That's exactly it. This is where those metrics we talked about earlier, EUI, daylight levels, water use targets, come back into sharp focus. You're using analysis tools, maybe energy modeling software, daylight simulations, etc., to estimate the actual performance of the final design. How does it stack up against the targets? The source mentions using a validation matrix, similar to the earlier matrices, as a tool to compare different design options or simply check the final design against those key performance metrics and the project's guiding principles.
And it's probably not always about picking the single design that scores highest on, say, energy efficiency alone, right?
Yeah.
It's more about balance.
Absolutely. It's rarely about optimizing just one thing. It's about evaluating how well the final design balances all those different perspectives we discussed: performance, systems, culture, and experience, and how well it aligns with the client's specific priorities. There are always trade-offs to be made, and validation helps make those trade-offs explicit and informed.
Okay, makes sense. And the presentation part.
The final presentation is crucial. It's not just about showing, pretty renderings of the finished building. The book really stresses that explaining the process, how the design evolved from the initial site analysis and goals through all the design explorations and decisions in Step 3, and how it was ultimately validated against the objectives, is vital.
So telling the story of the design.
Exactly. Communicating the why behind the design choices, showing how sustainability was integrated from the beginning, is key for getting buy-in and demonstrating the value of the approach to the client and other stakeholders.
Wow. Okay, that really was a comprehensive journey through the whole process, starting with that fundamental why, tying it back to our impact on the planet and the need for that triple or quadruple bottom line thinking. Then mapping out that clear 4-step methodology: context, pre-planning, design, and validation, like a real roadmap. And then diving into those fascinating specifics within the design phase. Harnessing natural forces through passive design, strategically bringing in daylight, really optimizing the building's skin or envelope, and carefully selecting materials based on their whole life cycle. It really shows there's a rigorous system behind making buildings truly sustainable.
I think the absolute key takeaway, the thing to really hold on to, is that sustainable design isn't some simple add-on feature. It's not a checklist you complete at the end of the project. It's a holistic, integrated, iterative process. It has to start right at the beginning with that deep analysis, understanding the specific place. It requires setting clear, measurable goals, exploring multiple possibilities, and then rigorously evaluating those possibilities against multiple criteria and perspectives.
And understanding this structured approach, even just the basics we've covered, it really changes how you look at the buildings and spaces around you, doesn't it?
Yeah.
You start to see the layers of decisions, how it's sited, where the windows are, what it's made of, and you appreciate just how challenging, but also how rewarding it must be to create spaces that work with the environment and genuinely serve the people using them. Every step truly matters.
It really does. So that wraps up our deep dive into the basics of sustainable design for today, guided by the insights from this book, Sustainable Design Basics. We hope exploring this methodology and some of these key strategies has given you some valuable clarity, maybe sparked a few aha moments about the buildings around you.
Definitely. And maybe something for you, the listener, to think about. If sustainable design is always about balancing these competing factors, performance, systems, culture, experience, and making trade-offs based on the specific context and goals, Which of those four perspectives do you think should carry the most weight or be the highest priority when designing a building for a particular community or place?
Hmm, that's a tough one. A good one to ponder. Join us next time for another deep dive into a new topic.